Well, hello again, everybody. Glad you're back. I hope everybody's doing well. Okay, today we're going to look at how computers work. I don't want to go too in depth. It's just going to be an overview of how computers work. So what I'm going to do, I'm just going to pop over here. Okay, little slideshow I put together. So hopefully you can see that. Yeah, how do computers work? Right, let's go. And what is a computer? I'm not going to read all this. I'm just going to try and give you the outline. A computer is a programmable electrical device. Okay, it processes information, and it's composed of hardware and software. So we've got two parts of a computer. Okay, basically gives you an input, you give it an input, it gives you an output. And there's a saying, put rubbish in, get rubbish out. Okay, so that's an old saying. Okay, you can store data on it, etc. Modern computers shouldn't be mixed up with the old outdated job computers. In the old days, when I very first started off, you had a server and you had a workstation. It was called NT server, NT workstation. And the NT workstation relied on the server backwards and forwards. And really it couldn't work. It could work standalone, but not very well. But now modern computers are now all standalone. And you can process your own information. One is a person and the other is a machine. Okay, so now individually you get a powerful machine to store your own data, your own apps, whereas in the old days you had to go to the server, get the app, and it used to come back. Okay, how does a computer work? Well, a computer processes the input to produce the desired output. Remember I said that just now. But it says here, but how does the machine outperform the human brain? Okay, that's easy. That's easy to explain. You can get a calculator up on a computer, work it out quicker than I can do it in my head. And my maths is rubbish anyway. They don't try to mimic the human brain. Instead, they run commands sequentially. The data is moving from the input, goes through the processor, and then output, and it's moving all the time. Now, in computers in the old days, you only used to get what they used to call one core, one maths processor. And I think in them days they were what they call 8-bit. 8 bits of information, 8 lines of information. Now you can get 64-bit. Okay, and here they're calling them neuromorphic computers. Okay, they can produce so much information at the same time because now you've got quad-core processors, you've got octo-core. So the speed of computers is getting faster and faster all the time. What's the difference between hardware and software? Well, basically, the hardware is the stuff you can touch, such as your keyboard, your mouse, your camera. Anything you can touch is the hardware. Also, the stuff inside your computer, the central processing unit, the motherboard, which we're going to look into detail in a minute. Not detail, but an overview. So anything you can physically touch. Software, on the other hand, what we call programs or apps, is not physical. How can I explain it? It's what we call software is what we call. It's written in a thing called binary, or it communicates in a thing called binary. Ones and zeros. One is on, zero is off. So you can't physically touch software. It's electronic. Okay, so that's the difference between hardware and software. Hardware you can touch, software you can't. Okay, computer works in 4 stages. The first stage is input. Lots of different input devices. You got keyboards, you got a mouse, you got a microphone, you got a camera, drawing pads. I'm thinking of getting one of those for future lessons. Yeah, drawing pads. Lots of input devices, sensors. We're going to be using lots of sensors when we start doing our Raspberry Pi programming. Step 2, it stores it. Different storage devices. We got the main storage, which is a hard drive. Different types of hard drive we'll talk about in a minute. Flash memory. You know, we talked about sticks, USB sticks. CDs, they're older. DVDs for movies. So, but they're older technology. Okay, so we store it on different hard drives, etc. It's then processed within the processing unit, the CPU, Central Processing Unit. And it's processed and gets transformed into output, the last step. Different output devices, as we can see. Screens, monitors. Okay, screens or monitors. Printers. Different types of printers. Then you got another one, speakers. Yep, speakers. So projectors. So lots of different output devices, just as they're same as input devices. So let's look at the hardware components of a computer, right? It's everything we can, as I said earlier, we can physically touch. And obviously the stuff, if you want to open your computer, you can see it. So CPU, graphics card, sound card, random access memory, RAM. Okay, it's all the physical stuff you can touch. The motherboard. The motherboard, it's the primary communication. It says up here, it's a board, the hub. I'll tell you an easy way to think of a motherboard. Think of it as the human body. Holds everything together. That's the best way to think of a motherboard. As you can see in the picture, lots of printed circuitry. They're all obviously important. Okay. And except the ones relying on Bluetooth or Wi-Fi. Without a motherboard, it's impossible to have a functioning modern computer. Right? So, if you're going to be using the Sunfounder kit, the circuits you build are the hardware. My board that I showed you earlier in an earlier video, my Freenove projects board, that's hardware. All right, and that in the Raspberry Pi. God, my mind's going. The Raspberry Pi, it sits on the motherboard. You can look at the Raspberry Pi. You can physically see the motherboard. It's got all the components soldered to it. Central Processing Unit. We've already talked about this. This is where all the processing goes on. Takes input, produces output. Think of the Central Processing Unit as your brain, right? Your brain. You know our brain's got different parts, but we're looking at what different parts of the brain do. So the Central Processing Unit is basically your brain, okay? It goes on the motherboard. It's the communications director, they're saying here. And I said, interprets input and instructions, sends out signals, okay, for the desired output. I told you earlier that you can have different cores. You can have a lot more cores, whereas before I only had one. Then I remember they went to a quad core, and now I think there's octo core. So computers are moving so fast. I tell you, technology in the last 20 years, the speed that it's gone through, the transformations. Then we've got RAM, random access memory. It works in conjunction with the CPU. Think of RAM as what you're thinking now. What you're thinking now in this moment of time. So, quick warning, say you're writing a letter in a word processor. You turn that word processor off. Oh, I want to finish that letter. You bring back the word processor, that letter's gone. Because, again, when you turn a computer off, the random access memory empties. It's like going to sleep. So, and when you turn it back on or open the application again, if you haven't saved it, it will be gone. So make sure you save your work or whatever you're doing, because it won't be there when you bring it back unless you've saved it. ROM, read-only memory. How can I explain this? It's firmware. It's called, you can call it ROM or firmware. It's what starts a computer. So you've turned your computer off and you turn it on. It's what they call it boots the computer. It loads what's called a boot loader. So what that does, it's permanent. It sometimes needs to be updated, but it's got the bootloader, it's got the information, the data there to start your computer. Okay, and as it says here, firmware is the first thing that kickstarts your computer when you switch it on. It's a simple program, it's not very big, but it just tells the computer where the operating system is. It's on the hard drive, load it. Okay, so that's what ROM, read-only memory. So remember, you've got different types of memory. RAM, random access memory. ROM, read-only memory. And the third one is storage. Different types of storage. Hard drives. Two types of hard drives. Solid state drive, okay, and hard disk drive. Solid state drive has no moving parts. It's all silicon inside, no moving parts. But HDD drive, which is this one here, has got moving parts. On this little arm there's a laser light and it moves across the discs. Similar to a CD. Inside is similar to a CD. And these discs are layered. Old school now. I think more people are going for solid state drives. They don't break as often. There's times when I've just knocked an external hard drive and it's gone forever. You know, it's buckled the disc. Because I think they are metal. They're not like plastic like a CD or a DVD. Okay, so there's two types of hard drive. That's where memories are stored. That's your back memory. Yeah, and when you think about something, say you think about something when you was a kid, that brings it to the RAM. So it's going from your hard drive to your RAM, random access memory. So basically think of storage like that. Again, we've spoke about different types of storage, hard drives, USB sticks. GPU, okay? This is the graphics. This is your eyes. The graphics side of it. Okay, what it does, it's visual imagery, so it's what projects onto your monitor. It processes the graphics side of things, like your eyes. Gamers have big, powerful graphics cards because it's so resource intensive that they need, because games, the colours, the graphics are so powerful, they need a powerful graphics card. But like the little Raspberry Pi, it's all integrated on the motherboard, normally in the CPU, but you can have a little separate graphics disc, because on a non-gaming computer, you know, just for normal everyday use computer, you don't need a powerful graphics card. All right, so it's different types of graphics cards. Sound cards, again, your ears. All right, sorry, not your ears, your mouth. A microphone's your ears. Yeah. I'm getting a little bit confused. Sound card, speakers. If you use speakers, you need a sound card. Okay, that is responsible for auditory data. So you've got your visual data for your graphics card, and your audio data is your sound card. Output to speakers, if you plug in earphones, normally the plug-in for an earphone goes into the sound card and it goes through. Okay, we're now going to look at software components. They're normally pre-written. We'll be writing a lot of software, well, not software, controlware, firmware, all sorts we'll be doing. But it's not a physical component, it's electronic. So you can't actually touch software. All right, it's what runs on the hardware of your computer. Okay, different types of software perform different roles and functions on your computer. So, computer architecture, I'm not going to read this because it's simple enough to go from this drawing. You got your hardware, okay, all the stuff you can touch. Then you got your basic input and output system, your firmware. This lies between the hardware and the operating system. It sort of brings the two together, if you like, and it's the one that tells your computer to start up when you turn it on. Operating system. This is the basic system, like when you start your computer up, you got the Windows logo, that's your operating system. All right, so lots of things running in the background. Excuse me. And then right at the top, you got your applications. So you got your operating system. Oh, I'm going to open my web browser. Bing, your web browser's an application. All right, so that is, there's more layers than four, but that's the four main layers. Let's go on. What's an operating system? It sits above the BIOS, below the applications, and essentially it controls the basic cores of the inputs and the outputs. All right, it's the foundation software. We know there's different types of operating system. We've got Windows. I don't know what the Mac uses. It's got its own operating system. Linux machines have got their own operating system. The Raspberry Pi that we'll be using runs on Linux. So all different operating systems. They carry out the basic input, output, and so on functions. They help with it. All right. BIOS, we've already talked about BIOS, the basic input output system. It's a link between the hardware and the operating system. I think I got this slide the wrong way around. I think I should have had it before the other, but not to worry. Strictly speaking, it's software. A program semi-permanently stored into one of the computer's main chips. Okay, so it's known as firmware. It's, as I said, it's usually designed so it can be updated occasionally. However, all BIOSes are specific to a manufacturer of a computer. Lenovo will have a different BIOS to Hewlett Packard or Acer. They all have their own versions of their BIOS. They're pretty laid out pretty much the same, but some are more powerful than others. You can do more on some BIOSes than you can the others. What are applications? We've already talked about applications, web browsers, email programs, word processors, spreadsheets, database presentation software, imaging, movie players, music making software. You get music making, video editors, social media platforms such as Facebook, Twitter, we can see it all here. Okay, and games. Lots of younger generation that we want to communicate with, hopefully, play games on computers. There are Xboxes, PlayStations, Switches, Nintendo Switches, and they all, majority of kids like playing games on them platforms. And they're PC games. PC, you can get some really powerful gaming PCs. Well, that's it, folks. That's me and how computers work. Please don't forget to subscribe and comment. Please comment. Anything you want to discuss that I know about or have a little knowledge. I say I've got a little knowledge in a lot of things. What's the saying? Jack of all trades, master of none. That's the saying. But anyway, I hope you enjoyed this video. If you did, as I say, please subscribe and comment. And hopefully next time you'll be back watching me talk about tech. Bye.